This conference will now be recorded.
All right, thank you everybody for joining us. I guess we're in a new year. Last year we had 5 sessions of mass timber discussion. It was kind of interesting seeing the progression. We had 3 sort of internal discussions where everyone sort of we're building our resources, getting up to speed, having that discussion, getting people interested. And then the last 2, we started getting more outside sources. We had Halliburton Forest come in, we had Thornton Tomasetti come in. I think those were really interesting sessions to get outside perspectives. And so today we have Brian from Code Red Consultants, and he's got a lot of stuff to talk to us about new code and mass timber. And take it away, Brian.
Thanks, Anish. And it's great to hear that, or that progression of perspectives, because obviously you all have your own thoughts internally, and then somebody like a Thornton Tomasetti is definitely one of the industry leaders that we're seeing on the structural side, with the probably like the 3 big, maybe 4 big considerations for mass timber being some order of sustainability and environmental impact. Certainly the economic model and how feasible is it from a bottom line and a dollar standpoint, which despite all the nice feel good stuff, that's usually what's at least one of the biggest factors driving owners or developers decisions as far as whether we're there from a feasibility standpoint, the structural design, and then the code compliance and the fire protection and life safety aspect of it, obviously, as well as all the aesthetics and the cool stuff that comes along with the mass timber buildings in general. So that's neat to get all those perspectives. I'm happy to be here to share what I've gone through personally and what Code Red has gone through on the project experience side. I've been tracking this for the better part of a decade myself, mostly from the beginning out of a personal interest, which Anish tells me that most of the people joining on this call are kind of share similar personal interest in this material and this emerging trend. It's certainly been fun to follow and see where the industry has gone. There's been a lot of advancement in places like Canada, Pacific Northwest, Midwest, but I think the Northeast is really making a push to catch up and show what we can do. So we want to help pursue that endeavor as best we can. I will go ahead and start sharing my screen. And is that working? There we go.
Yeah, it's working.
Okay, cool. So the way this slide deck is set up anyway, it is a presentation, but I'm definitely welcome. I'll definitely welcome any feedback or questions or anecdotes as we move through. This certainly can be as interactive as you all want it to be. But the 2 main parts of the presentation are, what can we do today under the current 9th edition of 780 CMR, assuming that we're practicing in Massachusetts, but that is the 2015 IBC. So what are our as of right options? And then a lot of focus on what is coming down the line with the 2021 IBC changes. How does that start to shape what the code is going to allow, and how does that affect our practice? And then for Massachusetts anyway, since the 10th edition is so far off, where are we left? Like, what do we do in the meantime in the next year and a half until the 10th edition is officially adopted, is based on what the prediction is going to be. And I have mostly just case studies of projects that we're either working on directly or some industry examples to help guide that discussion and highlight some of the code requirements. And then at the end, I'll talk about a couple different variances that Code Red has been involved with that recently got approved in pursuing taller mass timber. So not like 18 or 20 stories or anything like that, but certainly starting to push over the traditional 4 or 5, 6 story limits. A little bit about how some of those were achieved, and then just discussion on those processes and what we need to be aware of as we're going through projects that might need to have a variance. So this is AIA accredited. Anisha, I'll follow up with you afterwards for a sign-in sheet. If you could help circulate that or fill that out for me and get that back, we can get the credits, and then a copy of the PDF for the presentation as well, so you can have it on file. Just really quickly, I assume most of you are familiar with Code Red, but to the extent that you're not, we're a fire protection life safety code consulting firm. Office is about 35 strong now, most of which have master's degrees from WPI in fire protection. And then all the PMs have their PE license in fire protection. And we run the gamut on fire protection life safety, from traditional code consulting to fire protection, fire alarm design, performance-based design, fire smoke modeling, smoke control special inspections, fire stop special inspections, lots of construction-based services as well, phased occupancy planning, that kind of stuff, and then NFPA 241, construction fire safety. That is us in a nutshell. And then the outline is kind of already what I discussed. What can we do prescriptively, and then how can we push the limits? This group probably does not need this slide, so I'm only going to say a couple of things. I think you all already know what we're talking about when we say mass timber, that it's really made up of certain elements, glulam, which has been around for a while. When everybody talks about the mass timber movement, really it's CLT, right? CLT panels are the new thing that's allowed only as of the 2015 IBC as a new material. And whether you're 3-ply, 5-ply, I don't know if you all have seen 7-ply. I'm hearing that the 7-ply is not really on the table as far as a cost-effective option. But these are the materials that we're using in some fashion when we're talking about mass timber buildings. NLT floors, I'll mention for the UMass project, but otherwise we're seeing those few and far between, and I haven't seen DLT really used on any project so far. So sort of in chronological order, and I'll go along with some different construction types. A fun place to start off as an example, not that this is a Code Red project and it's now been built for the better part of 5 years. I hope some of you have had a chance to go see it, because they do public tours. COVID, I'm not sure exactly what they're doing with COVID. I saw it a couple of years ago, but the Olver building out at UMass, which houses the university's building and construction department, which is pretty cool for them, is a really great building. This was actually permitted under the 8th edition, and so this has been around for a while. They had to get some specific approvals since they were way ahead of the curve. But it gets called the crown jewel of New England mass timber movement a lot, because it's a pretty spectacular building, and they did a great job with it. You may already know a good amount about it. I like some of these photos from a construction standpoint, pointing out these big glulam columns. And then the floor system, interestingly, was a proprietary floor system, mass timber, and then concrete, which is what these metal tabs are intending to receive. And that does provide some increased fire resistance, but a lot of times, and in this case, it was provided more from an acoustic standpoint, and as I understand, a little bit of a structural design standpoint, to make the floor systems a little bit more robust, with some nice, great big spans between columns, some great aesthetics on the inside, exposed ceilings, exposed beams, columns, some diagonal bracing members, and really a lot of the aesthetics. When we talk about the drivers of these projects, a lot of it is aesthetic based. If somebody's going to spend the money on a mass timber building, they want to see it. And that's one of the things when we talk about the new code provisions that we'll get to, is one of the big things to stay aware of and to keep in mind when people get their hearts set on different ideas and concepts and renderings about mass timber is, when are we going to be able to have the mass timber exposed? And as we start getting taller, how much do we have to cover it up as sort of a penalty for going taller? Just some other photos from some of the interior elements. You'll note that the steel connections where they occur, and some even of these other steel members, this was a type 4 construction building, which doesn't have any true fire ratings assigned. And then the mass timber elements just have to meet the minimum dimensions and thicknesses as prescribed in Chapter 6. So these are not protected in this case because there isn't that fire rating requirement. That's some of the stuff that we want to keep track of as we're comparing these construction types to like a type 3A or type 5A, where you might need an hourly rating requirement. That being said, I think one of the takeaways from this building, and just starting to dive into some of the technical material, this building was type 4. And when we're talking about the current code and the prescriptive allowances or options that you have for construction types, these are really what it is. It's type 3, 4, and 5. Most people default to type 4. The code certainly crams all the mass timber requirements or provisions into the type 4 definition. But type 3 and type 5 both allow you to use any materials on the interior that are allowed by code, which now includes CLT and then allows for glulam. So type 3 and type 5 are on the table for mass timber design. These are the allowable heights and stories to get a flavor for some typical occupancies as to how high you can go currently. Assembly, business, and residential. So a lot of these buildings are being thought of in terms of residential, just like stick over podium buildings might be, but there's certainly some thoughts and approaches to using this for office buildings or mixed use, which is where some of the group A or assembly occupancies could come into play. So you'll note that if you want to push the current prescriptive limits, then type 4 and type 3A are the same as far as number of stories, and those are going to give your maximum allowable heights. You can go one more story for an office building that you can go for a group R residential building. What are some of the trade-offs between the two? The big drawback, and I'm sure you've already discussed this, but type 4 by definition is not allowed to have concealed spaces. So when we go back to the UMass building and you kind of look up at the ceiling, in a lot of the places, they're going to be exposed MEP infrastructure, which aesthetically and architecturally you can certainly make work, but from a building functionality standpoint, it certainly gets to be a challenge. And so far, I have not heard of any buildings that really can remove all concealed spaces from every part of the building. So this building, as I understand it, part of the variance was to have limited concealed spaces. That's also true of some of the variances that I'll mention later. So you have to at least know that you need to address that if you're going to go type 4 construction. Otherwise, type 3A gives you a little bit of a cleaner path in that aspect. Then the, not necessarily drawback, but thing to stay aware of for type 3A is type 3A is a 1-hour rating. So where type 4, you just have your minimum prescriptive thicknesses and dimensions for your different structural elements, type 3A, you need to have a 1-hour, you need to have 1-hour floors, you need to have 1-hour roofs. In both cases, you need to have 2-hour exterior bearing walls. So there's a little bit of a trade-off there. I personally have been advising most clients to head towards type 3 if it works out, just because there can be fewer hoops to jump through. But there's some other considerations for type 3A, like that prescriptively your exterior walls can't, by the letter of Chapter 6, have CLT in them. So if you want to have CLT in your exterior wall, that's another thing to keep in mind. So the point is that establishing your construction type is a good thing to do on any project early on, but especially if you're thinking or considering mass timber, then there's going to be some other considerations that you want to think through relative to what's allowed by code. So the UMass building was type 4. Here's a project that should be getting C of O this month. Actually, this is up in New Hampshire by the Pease Tradeport area. So this is the first CLT mass timber office building in New Hampshire. This is an SGA project. It's otherwise relatively straightforward. It's just a 3-story office building, about 75,000 gross square feet. It looks nice. They did a great job with the design. You can see a picture on the upper left, again, some nice exposed elements. But it is CLT floors, some CLT walls, mostly glulam beams and columns as the structure. And this size and shape of the building allowed us actually to drive down to type 5B. So again, based on the table, 5B, we can be up to 3 stories for an office. We don't end up with any hourly ratings. We don't have to worry about anything in the exterior walls. So there's no reason not to just drop down to the lowest allowable construction type for this building. A couple hurdles we had to jump over here. New Hampshire was still on the 2009 IBC, so CLT wasn't an allowable material at that point. So we had to have a meeting with the Newington building official in the New Hampshire State Fire Marshal's office, but the discussions went well. They were generally aware of mass timber as a movement. They were interested to support it, and they were okay with us using the 2015 IBC as the base design code for this building, especially knowing that New Hampshire was getting pretty close to adopt that as its base code anyway. So just a photo from construction, and again, this is due to get its C of O, and we'll be opening within the next 30 days probably. This is down in Virginia. This is from a previous life of mine. It's a 2-story building. It's HIT is a contractor down in that area, mostly Mid-Atlantic. We don't really see them up here. This is a showcase building for them. It's down the street from their headquarters. And they have this high bay space where they have some areas to do mock-ups to show off to their clients or other subs that they might be working with. They have a nice big conference room. And again, with such a small 2-story building, this was also allowed to be type 5B construction. Again, some discussions with the local officials, but otherwise nice exposed wood. And I show these not because they're terribly complicated from a code standpoint, but just these are real things that are being designed and are being built and are being occupied as far as what's out there for mass timber opportunities. So now getting a little bit taller, this is a project I'm working on. I think it's gotten some pretty good press, so it's pretty well known that this is a Place Taylor project. It is in design. It's a 5-story residential building, apartment buildings on levels 2 through 5, or apartments on levels 2 through 5 with some co-working space on level 1. Also fitting mostly within the prescriptive allowances, at least of height and area for the code, but it does need to use type 3A, or we chose to use type 3A as the construction type, again, to not have to deal with the restrictions on the concealed spaces of type 4. So this is CLT floors, CLT walls, not as many, not quite as many columns and beams, but you still have the glulam columns and beams that you can see on the photo to the right or the rendering to the right. This one is running against some restrictions for the CLT and the exterior walls that I mentioned. Another thing to keep ahead of is that the structural codes haven't necessarily caught up, and I don't know if Thornton Tomasetti mentioned this, but the shear wall design, if you're using CLT walls as your core walls and they're acting in a shear capacity, and this starts to get over my head from a little bit from a structural standpoint, but the NDS standards and the standard for shear walls, it's not until the 2021 edition that they recognize CLT as a material to be able to do that. So again, just on the code compliance side and things that we're tracking in case we need to go for variances and things like that, these are all the things that we're staying aware of. But this is a great building. It's racing to be one of the first mass timber buildings in Boston. It's also going for, I believe, net zero carbon, and then Passive House certification. So those are some pretty aggressive goals, especially for a larger commercial type building. I think, at least in my limited experience, that has been more on like the single family dwellings side. But we're seeing the limits being pushed there as well. Anish, I don't know, you had mentioned sustainability and some environmental aspects, which certainly come into play, and life cycle analysis and things like that. I don't have a whole lot on sort of like the code and life safety side dealing with that. I don't know if it's worth pausing to mention or rehash any of those goals or things that you've talked about internally related to some of these projects, or what you're seeing. And I guess I'm just curious as to how much of a driver that is for you all compared to, say, like the economic feasibility and the cost that we're seeing for some of these?
Yeah, I mean, I think it's kind of mixed. It's all of them at the same time, right? Because like even in Boston, we have like the net zero stuff coming up. There's a lot of sustainability requirements that we just have to have in terms of code.
Okay.
So yeah, that gets caught up. And so if it's easier to achieve with a certain type of structural system, like mass timber might give you, better thermal mass or maybe less. It just depends on certain situations. But yeah,
Sure.
so like it just intertwined.
Okay, good. That's good to hear. From an economic standpoint, I have been involved in a few different concept design exercises, and they've taken I guess the cost estimating and the feasibility models to different degrees of granularity. What I walked away with is that it seems like, compared to, say, like stick over podium construction or some kind of comparable light frame construction, the premium on these types of buildings is still somewhere maybe on the order of like a 10 to 15% premium, maybe upwards of like a 20. And I'm not sure what you all have heard or seen. That in large part is still driven, unfortunately, by the fact that we're not local to a lot of the fabrication shops, right? And so the suppliers are still existing in places like the Midwest or Canada or Pacific Northwest, or there's the newer one down in Alabama. There's a couple opportunities, it's sounded like, for a couple years up in Maine that we've been waiting on. It seems like those have stalled. I'm not sure exactly why. That would be kind of a game changer for us in the Northeast, because that gives us a more adjacent fabricator supplier location, because a lot of the cost appears to be in the transport of these materials, across the country from Canada. That Virginia project for a while was talking about shipping stuff over from Europe. Until those costs can come down, when that gets baked into the overall financial model, that's a pretty big restriction. Otherwise, as we'll see from one of the case studies coming up, the speed of construction, the ease of construction, the smaller crews that are required for these mass timber projects is a real advantage and can really cut down on the construction costs, but it does need to get weighed out and compared against the materials themselves and the shipping delivery costs. When we do get into the fire ratings, and we need to stay aware of it, I just wanted to go through a couple of the mechanisms there. There's generally two ways to approach this. The first is to do calculations to establish what the fire rating is and what the structural design needs to be. And that's mostly through calculating the char of the wood. So this technical report number 10, which is a subset to the NDS, tells you how to do that. The super general or the approach in a nutshell is to take your charring rate, which is somewhere on the order of 1.5 inches per hour, or 1.8 inches per hour for most wood species, and that gets applied against your required fire rating that you need. So if you need a 1 hour, you're probably losing somewhere on the order of 1.5 inches to 1.8 inches of your floor, say. If it's a beam, like over to the right, then you got to remember that that's exposed on 3 sides, so you're dealing with charring in multiple places. Your solid wood that remains in full strength is the beige color, right, that doesn't get affected by fire. You need to look at the different laminates of the CLT or the glue lam to know what is losing strength, not losing strength, and then the structural needs to design to that residual material that's left over that you can count on being there. So 1 hour, 1.5 inches, 2 hours, 3 inches, you're losing a decent amount of wood, and that sacrificial layering needs to be accounted for and proved out through all the structural calculations, which certainly get a lot more complicated than just that 1.5 inch easy calculation. And that's where you start to realize and understand the taller you go, the heftier these members need to be. For a 2 hour rating, you're you're usually needing to be in like a 5-ply situation as opposed to a 3-ply. But as you go taller, you immediately start to have some other design objectives that you need to meet on the structural side that may drive you towards a 5-ply anyway. And then you get into, do you need gypboard protection? Do you not need gypboard protection? Which also ties back into the aesthetics that we discussed. So the second option besides calculation is more and more we're seeing some listings in like the UL directory, which we're familiar with from non-mass timber stuff. But whether it's UL directory listing itself or there's test reports that you can get a hold of in many cases that different people are willing to share. But here's an example of a UL listing V329. If you're not familiar with UL listings, it's the number. It's some kind of image showing what got tested with callouts. And then as you step through the listings, it'll tell you what these different callouts are that get tied back to whatever rating it gets. So this is a bearing wall. You can get a 1-hour rating or a 2-hour rating. And here's the table that kind of guides what that would be. So if you only need a 1-hour rating and you're okay with adding gyp, then it's just a 1-hour layer of gyp on both sides. You can drop down to a 3-ply, which is kind of what this is sort of represents. If you need 2 hours, then you can go thinner with more gyp. You can go thicker with less gyp. And then the one that doesn't have any wallboard protection at all in this particular listing will get you a 1-hour rating. I can tell you that there are many other references at this point for walls and ceilings with a lot of different combinations of what can be exposed and what can't be exposed depending on what rating you need to meet. So again, these are good concept phase or SD phase discussions to have, usually between the architect, the life safety and code consultant, and the structural engineer to all figure out where we're trying to go, and then the contractors that do have good pre-con people that are into this mass timber world, they're starting to be more and more helpful to help drive those conversations as well. So that's something else to keep in mind. To summarize some of the takeaways on the prescriptive side, again, just identifying the minimum allowable construction type, always drive that down as low as you can, because that will help you in the long run. You can have exposed wood in these construction types that we've been discussing, as long as you're meeting the fire ratings. Keep in mind the concealed spaces for type 4, mind the fire rating requirements for type 3 and 5A. 5A, I'm not sure ever really helps, because I feel like you're either going to be going up against as high as you can go, or if you're a lot smaller, like we saw with some of those examples, 5B might be able to get you what you need. The one other thing I didn't touch on yet, even in like a type 4 construction, you're going to have fire rated shafts in your building, whether it's stair shaft, elevators, MEP. And as a reminder, the ratings for those shafts are 1 hour if you're 3 stories or less, or if the shaft connects 3 stories or less. 2 hour if your shaft's connecting 4 stories or more. So those ratings are going to have to be provided. And then a commonly missed thing is the supporting construction that you need for those shaft ratings. So maybe getting a 1 or 2 hour shaft isn't too big of a deal. And maybe those are self-supporting and you don't have supporting construction. But to the extent that you end up with supporting construction, that load path needs to get chased back down, and the hourly ratings need to be provided in that load path. So that's something else to take care of as you're going through the design for the project. All right. So moving out of the what can we do today prescriptively into the 9th and moving into the new world of tall mass timber. Again, another fun one to start with is the UBC Brock Commons Tallwood House, because this is pretty much the most exemplary mass timber building that we have so far. And it's a very cool example of what can be done. And that's exactly why they pursued this project and what they were trying to do. So this building was very much pursued as a showcase and a proof of concept piece to say, hey, mass timber is real. You know, the code changes are coming. We're going to be able to build this stuff pretty tall, and we want to show the world and and North America what we're going to be able to achieve, and that it can be designed, and that it can be built, and that it can be built quickly, cost effectively, that it stands up, that it provides a great space. So this building is CLT floors, again, glulam columns. Structural engineer could talk to the you know, what they would geek out on, I guess, on the structural design and why this is cool. You do notice that they do have concrete cores, as opposed to some of the other examples that we were talking about earlier. So that was a feature of the construction. And then I like this photo because it's really showing the limited amount of people and the ease that some of these panels are getting put into place. And then more than a picture, something else that's helpful is a video that's that they made available. And this is just a quick, like, 1.5-minute clip that I'll just throw up because the time lapse of this is all very interesting. This is an 18-story building, and the first story is concrete. The 17 stories on top of that are all mass timber, and that was the mass timber part was done in 66 days. So these things really go up fast. As you can see there, June to August. And over to the right, they show some of these infographics on kind of how this started to come together and what they did. That just said that they had 9 wood installers on site, 78 columns per floor. And as you can see it going through, they're just taking the crane, they're getting the panels in place, 5 to 10 minutes per column. And as you go through, the facade's able to chase up the side of the building. And as it says over the right now, 2 floors per week. So this is pretty impressive. You can see some of the equipment coming back to do the floor infill. Question came up recently on what the actual flooring was. I'm not sure if they used a concrete topping or just some kind of a gypcrete topping, but they were able to follow up with that and keep going, as you see. So very cool, great speed of construction. Great photo that they got out of it, which for this cool groundbreaking mass timber construction obviously harkens back to the classic construction workers on the beam. No boxed lunches or lunch boxes here, but the thing to start talking about with these tall buildings that segues into the code requirements for the 2021 IBC is, here's a photo of during construction and what the interior looks like from a structural perspective. But when you go this tall, you're not having exposed structure. So here are some photos as this building's occupied. It's a dormitory. So university students are living here. Inside, for the most part, it's looking a lot like any other high-rise you might go in that's concrete and steel. They were able to leave the student lounge up on the top floor partially exposed as a showcase piece. And then on level 1, there's a lot of exposed wood finish, really, because level 1's all concrete, that makes it feel like you're walking into a wood building. But for the most part, and they knew this going in, this was going to be encapsulated and encased in gypboard for fire protection purposes. And so when we come to the 2021 IBC changes, how they justified a lot of the new construction types and requirements was not just through some code discussions. There was, if you're not aware, there was actually some pretty extensive large-scale testing that was done on some mass timber and CLT mock-ups. So this is a photo from the ATF labs where they did this, and they ran 5 different tests of 2-story mass timber apartment mock-ups where it was fully loaded with IKEA furniture, some additional wood cribs that they distributed throughout to get the fuel load that they wanted. And as you can see, there were some pretty well-developed fires that came about from this. And what they did as part of the test is they varied the amount of exposed mass timber that was present in the units, and that's how they came up with this type 4, 5, or type 4A, 4B, and 4C construction types, which we'll mention in a second. They also varied the sprinkler protection that was available. In some cases, it turned on right away. In some cases, it didn't turn on at all. And in some cases, they delayed it for 20 minutes just to show that, hey, even if we have some relatively involved fires, the CLT panels do have the fire resistance that gets calculated, and there ends up being burnout, and we don't have a total loss or wildly uncontrolled fires in these types of construction. So these are the new construction types. And as you can see, the height compared to what we were looking at before is way higher. So the 2021 IBC now adds type 4A, 4B, and 4C to table 601 and in the definitions of chapter 6 as 3 brand new construction types. These are the first new construction types we've seen since, really in a long, long time in codes in general, but certainly since the IBC was formed in 2000. So this is pretty cool for the industry. Type 4HT is also remains in the code and stays the same as what we know of type 4 today. The differences in the construction types besides the heights that you're able to get, which is shown here, is what you have to do to protect these kinds of buildings. So as it states at the bottom, all of these have a 2-hour rating requirement as a structural rating requirement. So these are all going to be the equivalent of something like type 1B construction in the current code. And based on the heights, that's basically what they were trying to equate it to. All the way up for type 4A, you do also have you have 3-hour columns like you would find in a type 1A building. The other difference though is how much of the CLT and mass timber is able to be exposed. So you can see as we go right to left, it gets more onerous as you get taller. So a type 4C building is everything can be exposed, assuming that you still meet your fire ratings. Type 4B, we have some relatively minor amount or small amount of exposure that's allowed, 20% of ceilings and 40% of walls, which I'll touch on more on the next slide. And then once you get up to type 4A, everything's concealed. So that's more akin to the Brock Commons example, where you're not doing that building for aesthetic reasons at that point. In some ways, you're not really doing type 4B as much for true aesthetics, because you're going to have a pretty minor amount of your CLT walls or ceilings that are getting exposed. In these cases, you're really driving more at the speed of construction. Hopefully, again, for other places and in the future for Massachusetts, for cost reasons, once the economics balance out a little bit more. But I think that we'll see a lot at the beginning, and what we're already seeing for the case studies all show that the variances that we got, we're probably going to live in somewhere on the type 4C level, both from just how tall do we really want to go at first, and then most people still wanting to get bang for the buck out of having the timber be exposed. The other thing that I'll mention is that they address the concealed space issue for these new construction types. So concealed spaces now are prescriptively allowed. They just have to be non-combustible concealed spaces. So they have to be sheathed with gyp and be made to be non-combustible. But they are allowed, which they also have now allowed it for type 4HT in the new code. So that's where the industry is headed, which is good, because they've come around on the kind of impossibility of withholding that. And NFPA 13, the sprinkler standard, has treated that in a similar way for a while. So you will be able to have concealed spaces. Otherwise, this is what we're working with. When it comes to type 4B and how that's going to work, you can either have as it said, 20% of your ceilings be exposed or 40% of your walls be exposed. That's based on the floor area of a fire separated compartment. So if you're dealing with residential, all of your of one residential unit has, like a 1 hour boundary. You would take the floor area of that unit, and it's a percentage of the floor area that we're talking about when we say how to do this. If you want some mix between the two, there's some of the ratios calculation that you do, like the one that we do for mixed use occupancies, where you would just do the total for the ceiling over the allowable for the ceiling, plus your total for the wall over your allowable for the wall has to stay less than 1. So that's kind of summarized at the bottom 3 bullets here. You can either have all ceiling, which would be 200 square foot of an example, 1,000 square foot of apartment. If you had no wall exposure, 400 square feet of walls exposed if you had no ceilings, and then some mix of the two. In this case, the example would be 150 square feet of ceiling, 100 square feet of walls. That works out for your ratio to be 1 in that case, if you're going to mix and match. A lot of times, the walls aren't really getting exposed, and people are going for the ceiling exposure. And then because this is of the entire residential unit, a lot of times designers are congregating all of this in the living spaces. So keep the bedrooms and the bathrooms and the hallways regular ceiling, and then take your whole 20% and put it in like the living room and or the kitchen or something where it's a little bit more visible as you come in, as far as a strategy goes. But that's how those new construction types are working. As far as how they're being applied and what we're seeing, again, some of these buildings are more out west, but I'm sure you've heard of like the T3 building in Minnesota at this point, something like 7 stories. Portland's been doing like 8 and 12 stories. You see a lot of stuff in Europe that's pushing 8, 10, 14, 21, 24 stories. So those are getting a lot taller, as they've been doing that there for a little bit longer than we've been doing here. And then up in Canada, Brock Commons that we discussed is still pushing the limit, or is still kind of the leader as what's being done now. At the very end, I'll mention a couple US projects that are ongoing, but that's what we're chasing. And so as that relates to how we're starting to push the boundaries locally, both of these case studies that I'll mention are greater Boston area projects. And they both are above the prescriptive allowances, and we had to chase variances for both of them. And those variances were both approved very recently. So that's some great data points that we're gathering. This first one is a 7-story apartment building. This is in Lower Roxbury. The design wanted CLT floors and roof, glulam beams and columns. This ended up doing concrete cores. So again, compared to what we'd otherwise be allowed to do, the 9th edition restricts us for type 4 construction, which this project chose to go down for a couple different reasons. But we would again be limited to 5 stories, as I mentioned earlier, for a group bar building. 2021 for group bar would allow up to 8 stories under type 4C. Everything would still be allowed to be exposed. So where that leaves us within the 9th edition is that we chose to request 2 additional stories in height as our variance ask. So 7 stories as opposed to the allowable 5 within a 9th edition type 4 building. Some of the reasoning for that was that we thought the team thought in this particular case that staying within the type 4 lane might make the most sense to the board, since that's where it all gets documented in the code. The proposal was to include 2-hour structure, like would be required for type 4C, and then a limit to the amount of concealed spaces that would be provided, which were somewhere on the order of like a 15 or 20% of the floor area. So that was what was pitched, and we were careful not to say that we were going to comply with the 10th edition as much as, you know, the 2021 IBC and the upcoming 10th edition will allow this, and so we're asking for it in the spirit of the 10th. We don't know what the 10th edition is yet. We don't know what the amendments are. They haven't even been proposed or drafted. So for now, the variances need to be careful to stay within the 9th as much as possible, with some supporting justification, with kind of alluding to what's coming down the pike. But we can't really blindly commit to the 10th edition yet until we know more of what's going to be proposed, and those amendments are at least in like a final draft form. So that was one example, a Type 4 that asked for 2 additional stories. Another example is even taller, and it's not residential. This is office, 8 stories, 350,000 gross square feet roughly. Both of these projects are high-rise. They are over the 70-foot in height, and they knew that going in, so they have all the bells and whistles that a high-rise requires. This one including pressurized stairs. So this one took a lot of a different tack, though, where the 9th edition here would otherwise require Type 1B construction, and that would have to be non-combustible. The ask here was very different. In this case, we said that we're going to be a Type 1B building. The only mass timber elements that were proposed to be used were just the columns and the beams. And the floors, the walls, everything else, the roof was all non-combustible construction. So the ask here was, we want to be a Type 1B building. We're going to maintain our 2-hour rating, but our structure in the columns and the beams is going to be a combustible element as opposed to a non-combustible element. But we're still going to get the 2-hour fire rating. We did a little bit extra on the sprinkler protection side to make up for that. But otherwise, hey, the structure's 2 hours. You're getting the 2 hours, whether it's a wood column or beam, or whether it's steel with fireproofing. And so we feel this is a legitimate ask. The justification also brought in the concept of the 2021, although in this case, there was assembly that was up near the top of the building. So again, we had to be careful with saying purely that it complied with 2021 IBC, because I think it was going to be a little bit more in the Type 4B range. They wanted the columns and beams to be exposed in this case, but it was pitched this way and it was granted. And so here's another successful data point that we now have in, with basically a toolkit, right? Somebody's going to go first, somebody's going to ask the board these things, then you start to develop a little bit of precedent as you continue to move forward. So we were a little bit hesitant to use a totally different approach, but it's what needed to be done. And now that it's been approved, we know kind of where we can start to push the boundaries, and there's other projects that will continue to do the same thing. Along with both of these projects and some of the taller buildings, and even just fire ratings that are present in these mass timber buildings in general, some other things are popping up that I just wanted to quickly mention. Not all of them have actual solutions yet, but these are things that we want to stay aware of also early in the projects. And they are related to fire testing and fire rated elements that we've mostly solved for all of our other traditional construction, but they're presenting new challenges for mass timber. Things like fire rated joint systems. If you have a CLT wall and that meets a CLT floor, the head of wall joint that needs to be rated, that's almost always up against a gypsum ceiling of some kind. That's not really going anywhere. If you have an exposed CLT ceiling that's going to burn away and char, what is that detail? What kind of intumescent sealant do you need? And how many listings are there, if any, so far that Hilti or STI or 3M or whoever has run? For other projects, that's pulling, either flipping open the UL book to something that is going to be there anyway, and it's just a matter of finding the right one, or going back to your ELCAS stable of pre-approved joint details that you always use and used on the last project or something like that. And because of the nature of that, a lot of times that's happening at right before permit, or somewhere in CDs, because that it's there. It's just a matter of putting your fingers on it. This probably needs to be a lot more of a proactive approach or discussion that happens earlier, like at the late SD or sometime in DD, so that there's time to talk to the manufacturers and see what's available. Same thing for something like a slab edge fire safing system. What are you doing at your slab edge if you have a CLT floor versus something else? NFPA 285 compliance and combustible facades. A lot of times for the taller mass timber buildings, you're being limited as to what your combustibility is anyway, and you're going to have a non-combustible veneer and or insulation. So it might not be too big of a deal, but you still could have like a type 3A building or a type 4 building that doesn't have that restriction, and you might need to solve for that. Penetration, fire stopping, same thing. And this photo is actually from a Hilti example where they are starting to run some tests with some penetrations, and so they can get more of their listings. But we need to chase through this, especially not only do we need to get it right for the design anyway by code, but for any of your high-rise buildings, you have a fire stopping special inspection requirement. So this stuff is going to get vetted, it's going to get analyzed, somebody's going to ask for your UL listings, and someone's going to be inspecting it as when they come onto site during construction. So the I's need to be dotted, the T's need to be crossed. And then even non-high rise in the 2021 or maybe the 2018 IBC, all residential buildings, I believe, have a fire stopping special inspection requirement anyway. So as soon as you're residential, this is going to come into play as far as having that extra level of scrutiny. So again, all project specific solutions, but just as far as sharing what we're seeing and things for you to keep in mind as you're working through the design and things to stay aware of. I'll conclude and try to leave a little bit of time here for Q&A and some discussion. But a couple other cool projects that are in construction right now that I just wanted to share quickly. This is in Cleveland. This is called the Intro Building by Harbor Bay. It's a 9-story residential. It is under construction now, and they're delivering it for spring 2022. So again, just this stuff is real. This is what's being done, and this is what's coming. In Milwaukee, this is the Ascent. This is a 25-story tower. When this gets completed also for 2022, at least as of right now, this would be the tallest mass timber building in the world, certainly in the States. And so this is something else that's pushing the limits and has been approved, is being built. There's a lot of support for these buildings in some of these areas from the local timber associations, timber industries, state governments, that kind of stuff. So there's funding that they're getting, and these places in some ways want to be first to the table and be able to brag about what they're building and how high they're going, and the fact that like, hey, we can do this. So all stuff that continues to be great for the industry, and I assume for all of you who are interested in mass timber, interesting data points and project examples to see what's going on in other places. So with that is the content and the knowledge that I have to share. I'm sure there could be several questions and or comments back, and I am happy to talk about whatever is on your minds as I went through all that.
Awesome, thank you, Brian.
Yeah, Anish, what do you think? Was this the kind of stuff that you were hoping for and expecting for content? Are there areas that you were hoping to hear about that I didn't hit on?
Yeah, I mean, I think it was super comprehensive. It was great, especially to see like the examples and how, a lot of this is still interpretive, and you still have to go out there and put yourself out there with the AHJs and explain yourself and figure it out. And yeah, it was great. Yeah, I mean, let's see if anyone else has a question before I ask questions, because I have some, but let's see. Anybody else? Okay, well, and I'll ask. I mean, I was going to ask like that variance too, right? You had the wood structure and the non-combustible floors and walls, but almost if you think about the reverse of that too, or even for all these hybrid systems, how do you think it's actually going to end up being thought about in terms of type 1B or type 4B? Because those seem more broken out in terms of like it's a steel and concrete building or a mass timber building, but how do you think these hybrids, especially as we're trying to get this new adoption in, maybe we'll only get CLT floors or one little piece of it CLT. How do you think that'll get slotted in?
Yeah. It's a great question, because a lot of these, I think what we're seeing is that some are going pure mass timber, but a lot of them are hybrid. And what do you do? And even Mark Sardinia's question in the chat that we had before the holiday break, which kind of spurred this presentation in the first place, was, hey, if I have whatever I have, an 8 or 9 story existing non-combustible building, and I want to throw 2 stories of mass timber on the top of that, how does that work? Can I do it? Anytime you have hybrids, you're technically required to default to your lesser construction type. That's what the code tells you to do. And so then it's a matter of figuring out what that means. So if you plop 2 stories on top of a 1B building, then technically you're dropping your whole building down to whatever, type 4, type 3A, whatever it might be. You immediately start to think, well, how does it work in practice? If I treat my roof like a 3-hour podium, in essence, does that solve it? It certainly starts to get at some great mitigation from a performance standpoint and what we actually are worried about in the building and the hazards, but it doesn't necessarily have a path through the prescriptive code. It's more along the lines of how you're going to fill out your justification section for your variance. So to your question, Anish, it does default otherwise. So for the variance 2 example, if it was all non-combustible, it would be type 1B. Since it had its timber, it really does drop down to like a type 4. And again, we flipped it on its head for what we wanted to go with. In the type 4C and the 4B examples, it's not going to matter as much anymore, because say you had a true type 4C building and you wanted to do some of it out of non-combustible construction or have some steel columns or beams or whatever, for whatever reason, you already are defaulted to the lowest construction type, which is type 4C, and you're allowed to have your 8 stories or your 9 stories. So it no longer becomes a hybrid issue since you're meeting the minimum. I think it's only going to stay an issue if in the meantime, when you have a building that it almost always comes down to a deficiency of allowable height, either in feet or in stories, when you have an hybrid building, and then it's just a matter of which way you skin the cat as far as how you're going to present it and justify what's going on.
Cool. Makes sense.
There was also the thought for that building that, hey, what's worse actually? If I had mass timber, if I had glulam columns and beams, or if I had mass timber walls, roof, and floors. The mass timber walls and floors would be adding a lot more wood content to the building, right? As far as like a combustible load within the building, you'd have a lot more in that situation versus just having the structure be rated or the structure be wood.
Yeah, I mean, it just seems always so funny that it's split between combustible and non-combustible. It's like disingenuous words, right? Because it's all combustible. It's just different perceptions of the material. But yeah.
Out of curiosity, are you seeing for the various opportunities or concepts that Alkes has gone through, would you say that stuff staying on the lower range, like the low rise, or are there things that are being pushed up, being contemplated for taller, true taller mass timber buildings, the 7, 8, 9, 10 stories, or what is it that you're seeing on your side?
Well, I think we have one project that's like a 2-story, like a 3-story mid-rise academic building that is on the books, but outside of that, it's more just speculative for high rises because, we're still uncertain about the code, and it's more like further down the line projects that I think are thinking about mass timber. The ones right now that we're trying to get out the gate, I think, I don't know. Sometimes it seems like we've already missed that window of even thinking about it because a lot of our construction processes are so like front loaded that we bring in contractors super early on and they're already picking out all these different structural types, and you try to add something later on in the conversation, it seems like we've we've already missed that conversation. So
Yeah. And if you don't have a developer or an owner that is gung ho on mass timber in general, it's probably a lot tougher to convince them to go mass timber as it is to just help them facilitate a vision that they already have, right?
Right.
Yeah,
Especially with the exposed wood. Oh yeah, sorry, go ahead, Kristen.
No, that's all right. I was just gonna say, I think some of the university work that we do, they drive the interest in this, and basically, as an embodied carbon, kind of, and the looks too. And then it also works for timing of student housing needing to go up pretty quick. But otherwise, I'm not hearing other projects being as interested. And I think you're right, Anish. It's really a lot of, kind of typicals that we're doing. But I think that what I think will change things is when that facility comes, or the two facilities I think in Maine come online. I think that'll help a lot. Our project in Maine is actually I believe we're getting the wood still from Austria, and that's the least expensive and actually the least footprint versus
Wow.
training it or trucking it across the country. Maine USM really wanted to have it be a signature thing for their state, but
Yep.
the facilities just aren't there yet. But I think when it is available more here, that the interest will pick up. And then I think what we're seeing too with the zero codes, they're going to start to talk about embodied carbon and having goals for projects on embodied carbon, and that will really drive the interest more.
Sure.
And by then it should be it shouldn't be a premium, hopefully in a few years. So
Yeah. It's also interesting, Kristen, I don't know if it came up on your project or not, but I need to circle back around. Maine, I think, was supposed to issue an emergency code change that would allow mass timber, I think, under the 2021 provisions, even though they're going to be on the, what are they on, 2015 for a while.
yeah, I'm not that deep into the project to know what they dealt with. I do know that they did start with a hybrid building, and not necessarily a hybrid system, but like half the building was mass timber where it would be exposed, and the back of house stuff was going to be steel frame, and the contractor ended up finding out that it was a lot cheaper to go with mass timber throughout. So we switched, but which was surprising to everyone. But they're getting their cost package back this week, so hopefully we'll find out more, their final cost package.
Is that Consigli by any chance?
No, it's out of Portland, Maine. I want to say PC Construction.
Yeah. Okay.
Well, cool.
That was very helpful. Thank you so much.
No, you're welcome. And as you mentioned, like, universities rightly being up on it. And so for any, for conversations that you're having with either developers or university clients, as they're kind of teasing it out, I'd be happy to jump into any of those conversations, or do like a prep session, or review any of this material that we talked about, because I think it's the more everybody can learn and stay cross-educated on the various aspects is really what's going to drive this forward in general for the feasibility of the projects. And I know that there's a lot to track as far as the structural options, which, I have a couple of my structural friends on speed dial to ask them the mass timber structural questions. And then it's usually a two-way street. They'll pick up and say, like, hey, can you walk through that construction type thing, or the fire rating thing with me one more time, or what you said about the fire rated joints, or how does the variance process work? Like, when should we go for the variance? When should I start talking about that on the project? So happy to have those conversations if or when they come up.
Great, thank you.
Yeah, you're welcome.
Yeah, and you'll send out send me the sign-in sheet and I'll pass that around to everybody that
Yes.
came to the meeting, and we'll get the AA numbers too.
Yeah, that sounds great.
Great, thank you. And then I'll post this on Emmy for everybody else who wants to go back to the recording. And have a good afternoon, everybody, and weekend.
Awesome. Thanks, Manish.
Thanks,
Thanks, Ryan.
Good to see you all.
Thank you.
Bye.